Hi everyone, let's talk about circuits. So if you remember the beginning of this chapter, you have seen Ohm's law, which is basically the voltage on a given resistor is going to be whatever the current you're reading on that resistor times the resistance value of that resistor. So V is equal to I times R is what we call Ohm's law, and most of the general resistors, commercial resistors, are ohmic resistors. There are different ones, but general resistors are basically follow this rule that we call Ohm's law, which is voltage is equal to current times resistance value. So if you take two resistors and connect them in series, just like this as I showed you here, one after another, you have pretty much the most basic circuit. You can have only one, then in that case it's the simplest circuit. When you have two connected in series, is one step further in the complexity, but it's still one of the simplest circuit. In this case, what you have as effective resistance value, instead of one single, you have two in series connection. The total resistance, let's say, is generally the question in these concepts. But you know that both of these resistors are ohmic, which means that they both follow this law, which we call Ohm's law. So V is being the battery or voltage source, I is the current that is flowing through your circuit. So this is the basically conducting loop that the current is going to be flowing. So if you put an ammeter to measure the current on R1, you're going to read I value and a current value, and the same thing goes for R2. And in this case, because there's no other loop that I can follow, that's like as if there is one single pipe that water can flow in, right? It's the same thing, like you have one single loop shape pipe that water flows in it, and the same water basically goes over R1 point and R2 point. So the current in this case is going to be flowing over R1, and R2 is the same current because there is no other path that it can follow. Therefore, you know that the current that you will read for R1 is the same current that you will read for R2. What happens in this circuit, as you see, the voltage that you apply is going to be shared between these two resistors. Therefore, you can say voltage, the total voltage that you have in your circuit, is going to be V1 plus V2. Basically, if you connect your voltmeter on R1 and R2 separately and measure their values, you will read voltage 1 for R1 and voltage 2 for R2. They're going to be added up to whatever the value that you apply to your circuit. So, and knowing that both of these are values are, obeying Ohm's law, you can write V, the total voltage, as the current in your system, in your circuit, times the R equivalent. Equivalent resistance means the total or effective resistance of this combination that you have here. So we use equivalent to just designate that if you replace this whole combination thing with one single resistance, what should be the value of that single resistance to replace and just have the same effect on your whole circuit. So that is called R equivalent. And we know that the same current passed through R1, so the V1 on R1 is going to be I times R1. So I'm writing V1 by just following Ohm's law, really. And I times R2 is going to be V2. Okay, so because each resistor is following Ohm's law, for each resistor the voltage value is going to be current flowing over it times the resistance value of that resistor. So the same current is flowing through R1 and R2 dictates that these I's are all the same. And I'm just imagining that as if I put like a box over this too, and imagining that what would be a single resistor inside of this thing. Like if I put the box here and say that what is inside this box, what is the value of this resistor inside this box, would be your answer for R equivalent. So it's basically total resistance or effective resistance is what we call R equivalent. Because we have I on all of these terms, you can basically divide both sides with I, the current, and then you're going to get rid of I by doing that. It basically gives you how you can find R equivalent in a series connected circuits. So in this case, we have only 2. However, you could write 3, 4, 5, no matter what number of resistors you have in this box. I don't know. What you would do is to add I times R3, I times R4. So in series connections, if you have resistors, multiple resistors connected in series, meaning that they are basically connected one after another, the total resistance value or equivalent is going to be addition of all of those resistance values, okay? So it's that simple. So if you have R, for example, R1 to be 2 ohm, that is the ohm is the unit of resistance, R2 is, let's say, 6 ohm, your R equivalent, and in short, I'm going to show it as REQ, is going to be 2 plus 6, 8 ohm, okay? So this is how you find equivalent resistance for seriously connected resistors. And one question here could be, if your voltage is, let's say, I don't know, 2 volt, what would be the current flowing through the circuit, right? So in this case, I mean, most general questions are these kind of simple questions, like you're given R values and B value and asked I, or you're given, like, I don't know, the other parameters and asked for one of the unknown. So in this case, I asked for the current, so let's calculate current. So the beauty of Ohm's law is that it basically holds for the whole circuit as well as the individual parts of the circuit. So in this case, as I wrote here, V1 is equal to I times R1. However, I also wrote that the whole V is equal to IR equation for the whole thing using the R equivalent. So I'm going to write it for the whole circuit. Voltage is given as 2 volt. Current is the question, and our equivalent, as I calculated here, is 8. Therefore, the current flowing through the circuit is going to be 2 over 8, which is 0.25. Yes, 0.25 ampere in this case. Okay. So let's talk about parallel connection. In this case, the parallel connection is going to be the case where you have, again, let's use just 2 resistors. You just really connect them like visually in parallel. This one is a little bit tilted, so let me try to do it a bit better here. So voltage is going to be here. So you're connecting your battery like this in this case. So let's say this is R1 and this is R2. This is how a parallel connection looks like. So again, your voltage source is going to supply your current, but in this case, when it comes to here, as you can see, it's going to split into 2. It's like as if you have kind of system of pipes that carries the water. In this case, at this junction, some part of the water is going to flow this way and some part is going to flow this way. So the same thing happens for the current. So when it comes to this junction, it's going to split into 2. It's going to follow over R1. So let's name that current I1 and this current I2. It's going to flow over the resistor and just emerge on the other side. And when they merge back at this spot, at this junction, the same I, they're going to add up to the same I value, and the same current value is going to go back to the voltage source. So in this case, they share the current, as you can see, and because you apply the battery to the end of each resistor separately like this, you would know in this case the voltage is going to be the same for these 2 resistors. Again, let me repeat this. In series connection, they share the voltage, so you write this, like the total voltage that you apply is the addition of all the voltages you have on each resistor. And in this case, it's really the current that they share. So you can write I is equal to I1 plus I2. And once again, we are going to use the Ohm's law, which is V is equal to IR, and which you can basically reorganize and write it as V over R, right? It's the same thing, same equation, different form. Current is equal to voltage divided by resistance. So let's apply to this one. In this case, I is the total current on the whole system. So once again, if you put like a whole box over this and imagine that there's single resistance value, what is that value? That is what you call R equivalent again. So that is going to be total voltage divided by R equivalent, which is going to be equal to addition of these two currents. One is over R1, one is over R2, so it's going to be V divided by R1 plus V divided by R2. And once again, the voltages, because the voltage is applied on the end of the resistors separately for R1 and R2 here, although they're looking like they're merged, the same voltage is going to be read. If you put a voltmeter on R1 and R2, you will read the same voltage. So you have V values the same in the parallel connection. Therefore, you can just divide both sides with V and get rid of the V from the equation. And if you reorganize this thing, you see 1 over R equivalent is equal to 1 over R1 plus 1 over R2. But I find that when you do this calculation, you forget to reciprocate. So I like to write for the parallel case, and let me put P here. In the same way, let me put S here for the series connection. For the parallel connection, your R equivalent is going to be reciprocation of this thing on the right you have, which is 1 over R1 plus 1 over R2. Once again, this is 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So I reciprocated it and got this. And I like to give this formula in this form because if I leave it like 1 over R equivalent is equal to 1 over R1 plus 1 over R2, people do this part and then forget the reciprocated. So I always find it safer to give the formula in this form. And once again, if you add R3, R4, I5 all in parallel connection, what you would do is to add here 1 over R3, 1 over R4, and goes like that. So once again, let's see if you have 2-volt battery, what would be the current on the main branch? What is the total current basically for the circuit? And again, let's take R1 to be 2 ohm and R2 to be, what do we take? 6 ohm? Yeah, I just want to show you how numerically they're going to look different. So if that's the case, let's find R equivalent. So in this case, R equivalent for this series, for the circuit is going to be 1 divided by 1 over 2 plus 1 over 6. That is going to be 3, so it's going to be 4 over 6, so 6 over 4, so it's going to be 1.5 ohm. So again, you will do this with calculator. Be careful, put I don't know, proper parentheses, or just do the calculations step by step, just so you don't get wrong answers. Okay, so try to repeat these calculations yourself with the calculator so you know that you're getting it right. So once we have the R equivalent, we can actually use again Ohm's law for the whole circuit by using it for the total. So the voltage given was 2 volt, I is the question, and R equivalent as we found here is 1.2. Therefore, our current is going to be 2 divided by 1.5. So 2 divided by 1.5 is going to be 1.33. Actually, it goes on, but I'm going to just write 33 here. So this is basically how you solve for simple circuits. For series connection, for parallel connection, the formula is different. So you just keep in mind that in series connection, they share the voltage. In parallel connection, they share the current. Those two things are important. So write them down as a note for yourself, please, in your cheat sheet. And for series connection, the equivalent resistance value is the addition of all the resistors. And in parallel connection, it is basically 1 over R1 plus 1 over R2 plus 1 over R3, how many ever resistors you have. So it goes on like that. So I hope this is going to be helpful for your understanding of the connections. And have a good day.